In the research Dr. Biffinger and I are working on, we are synthesizing polymer polyurethanes with reversible metal coordination sites, and then we're electrospinning those polymers into photodegradable fibers and hydrogels. What we're going to use this for, among the many possible uses, our main application to start off with is for cell culture, research, and scaffolding.
Polymers have transformed our lives since the early 1920s, including in tissue engineering scaffolds in the early 1980s. Depending on the functionalities used in the coordinating polymers, you could remove heavy toxic metals from water, you could use these polymers as Lewis acid catalysts, you could also create self-healing or conductive materials or even flexible photovoltaic materials.
The impact on in vitro research is that this allows us an additional way to manipulate and study cells using that spatial and temporal control of the mechanical support structure provided by those nanofiber mats.
The synthesis of metal coordinating polymers was difficult since many of the polymerization methods are not suitable for modified polymer backbones. However, we have taken advantage of recent advances in bulk melt condensations with sustainable non-eutectic acid-based catalysts to synthesize polyethers with nitrogen ligands.
So because of the similarity of nanofibers to the body's natural extracellular matrix, these nanofibers make excellent substrates for cell culture. Even so, they aren't quite as good as what the body makes itself, what the cells lay down themselves, this extracellular matrix. And so, even though we need these to support a cell culture to start with, we'd like it to disappear in the long run. And that's where the degradability comes from. So the degradation of these polymers is good because it allows the cells to eventually live in an environment of their own making, which is very good for them to simulate the activities that they'd be doing on the body. In vitro research, we're trying to recreate that exact physiological condition in a dish so we can study it.
We then chain extended them with diisocyanates to create a low molecular weight polyether polyurethane. We will then ultimately take 4 and 6 coordinate photosensitive metal centers and electrospin these materials into fibers.
While synthesizing the metallopolymers has its own challenges, the properties of the polymers have to meet several requirements. To actually process them into nanofibers by electrospinning, they have to be turned into a fluid or working solution which has a narrow range of viscosity, conductivity, and polymer entanglement that actually lets it form these nanofibers.